Friends, today we are going to discuss the industry's workhorse which is required for every industry to transfer fluid from one place to another place with high pressure and parameters. This equipment is called pumps. Before we're going to discuss in detail of pumps, we just want to narrate you the classification of pumps. Classification of pumps is two types. One is called positive displacement pump, another one is called dynamic pump. Positive displacement pump can be of again two types, rotary and reciprocating. Again, reciprocating can be divided into two types, that is diaphragm type and piston and plunger type. Similarly, rotary can also be divided into two types, single rotor or multiple rotor. Like this, dynamic pump can also be divided into two types, centrifugal and axial. So what is the main difference between positive displacement pump and dynamic pumps? Now, positive displacement pump trap and move a fixed amount of fluid with each cycle. What does it mean? Means every cycle the positive displacement pump are bound to deliver some fluid with pressure. So this pump particularly used for minimum flow and high pressure application, and its working variation is very limited. It's very limited. Now, this positive displacement pump, we are using parts like piston, gear, lobes and diaphragm. Dynamic displacement pump are used for high volume, low pressure application. If you keep the discharge valve closed, then there will be no flow, but still pump will go on running. It will run with churning. So it is a wide range of operation. We normally use centrifugal pump, dynamic pump, and the main parts of centrifugal pumps are rotary parts and stationary part. Rotary part includes impeller, shaft, bearing, and stationary part include casing, diffuser, suction nozzle, discharge nozzle, etc. So we are going to discuss today the centrifugal pumps and its parts. Now, what are the main parts of centrifugal pumps? That I have already informed you earlier slide, that it consists of two main parts. One is rotary component and another is stationary component. Rotary component, if you see the right hand side diagram, it is shaft, it is rotating. Along with shaft, the impeller is also rotating, lug nut is also rotating, bearing is also rotating. In stationary part, there will be stuffing boxes, casing, diffuser, suction nozzle, discharge nozzles, bearing housing, etc. They are the stationary part. Here you can see the left hand complete industry pump, that is, it is taking suction from horizontal and giving discharge vertical. Next is the cross-sectional drawing of a single stage pump. You see this is the shaft, this is the bearing portion of the shaft, and this impeller is mounted on the shaft. This is the suction, and this is on the volute casing and discharge. Now we are going to tell you the different parts used in centrifugal pump. There is one very important part we are going to discuss today is the wiring ring. Wiring ring can be of two types. The wiring ring which you are going to use in the casing is called casing wiring ring. You can see this is a ring. It is a ring construction. It will be used in casing. And another one wiring ring we are using, that is actually mounted on impeller. This is the impeller. Here it is mounted. You see this one is mounted. This is called impeller wiring ring. What is the purpose of wiring ring? It can be used in the suction side as well as the discharge side of the impeller. What is the purpose of wiring ring? The main purpose of wiring, if I do not use wiring ring, then pump suction, discharge will be there. So impeller both sides will be discharge pressure. So the one impeller is rotating and casing is stationary. So there will be a tremendous pressure drop between this with this casing with the casing and suction of the impeller. So due to this low clearances pressure drop, there will be erosion. Either your impeller may worn out or casing may worn out, and the replacement of impeller and casing is a very expensive one. So we don't want to do that. So what we are going to do, we are going to use the wearing ring, both casing as well as wearing ring, and maintain a very close clearances, so that the discharge from the discharge side or from the palm, this side, very few, very low, less quantity of water pass through this annular space and go to the suction, or maybe discharge to stuffing box, or through hole it may come to the suction again. So this is the main important part. It increase the efficiency of the pump, because by restricting the flow. Second is, if you it is a softer material we are using, so maximum worn out during running. When the flow take place running, the fluid will pass through this annular space. So worn out, this wearing ring will worn out fast, because it is softer than the material of the casing and impeller. So it is very easy to replace this worn out part, that is a casing wearing ring or impeller wearing ring. You need not require too costly replacement of the impeller as well as the diffuser. They are the two important functions this wearing ring are performing here. You see, the reduce the leakage, to protect the expensive equipment and maintain the efficiency. Means if you are maintain the close clearances, then your efficiency will increase. Next is what is the material of the wearing ring. The two materials should be such that, because one will be stationary, another wearing ring will be rotating. So the two materials should be such, so that the hardness of the material to be chosen in such a way that it prevent galling. Galling means seizing. When it is running, one impeller, one stationary part and one rotary part will come in due to coach clearance and high temperature. It may metal to metal contact will be there, and it can seize. But so the material should be such, to different material you have to choose, so that seizing due to galling can be avoided. Rules of thumbs telling that wearing should be softer than the component it protects. Means if you are protecting the casing, so wearing would be softer than the casing. And if you are protecting the impeller, so impeller wearing should be softer than the impeller. And harness wearing reason it wears out instead of the impeller. Okay, so it will wear out. Harness will be less, so it's wear out fast. So you need not replace. You have to replace the wearing only, not the casing or not the impeller. Typical material and hardness of the wearing ring is, hardness is its Biennial hardness number, means HB, that is B is B scale. Rockwell hardness number, C scale. Wearing ring will be impeller wearing ring will be bronze, stainless steel, cast steel, which with hardness Biennial hardness number will be 150 to 250. Similarly, casing, it can be cast iron, it can be stainless steel, and its hardness will be 150 to 220 Biennial hardness. Then second important items we are going to use here in the shaft, that shaft sleeve. Why shaft sleeve we are using? Because shaft sleeve, the purpose of the shaft sleeve is also same. When we are using fluid, corrosive fluid, so corrosive fluid if come in contact with the shaft will erode or maybe corrode it. So to avoid that, we are using shaft sleeve. This shaft sleeve, it will be mounted on the shaft with a key, so that fluid will not come in contact with the shaft. Shaft is also a very expensive items. So replacement of shaft is very expensive, as well as the very time consuming, because once when you want to replace the shaft, you have to take out the shaft from the bearing housing, from the bearing housing, so it will take long time. Again you have to put the bearing and fitting the bearing into the housing, so long time. Instead of that, if you are using the expense shaft sleeve, then you can very well remove the shaft sleeve and put it back again, so there is no need of replacement of any bearing and etc. So your time will consume, your time will save, but the property of sleeve should be higher than the shaft, because it is than the shaft. These are the purpose of the shaft. It protects from wear and corrosion and erosion. Therefore, it is called the sacrificial component, because need not require to replace the expensive shaft. Easy to maintenance for replacement, because you need not take out from the bearing, so it can be easily, and do machining of the remachining of the shaft. Entire shaft is impossible and time consuming. That can be avoided without disturbing the main shaft alignment. There is no need of doing anything, because as you are not taking out this shaft from the bearing, so there is no need of doing any alignment also. And the sleeve make a very important function, that is maintain the axial gap of the impeller with the casing. If it is a multi-stage pump, then between impeller we are using a spacer that will maintain the impeller position just in the middle of the diffuser. That's the middle of the diffuser. That's why increasing the operation will be the more smooth. Now, material of shaft sleeve should be certainly be harder material than the shaft, because it should when the corrosive material, it should not be corroded, it should be hard. That's why the material of the sleeve should be higher than the shaft material. In normal cases, we normally use the SS martensitic SS AISI 410, 420, austenitic 316, 304, most commonly used for good corrosive and wear resistance. For non-corrosive material, we are using bronze and brass alloy. For chrome-plated carbon steel, we are using for wearing, for hardness and wear resistance. For very high erosive service, we are using extremely corrosive or erosion. Then we are using EN24. EN24, and that's why here the sleeve should usually made harder than the shaft to resist wear and should not be corrode and corrode. Just like casing or impeller, it should be wearing rings material should be softer than the casing and impeller, so that these will worn out fast and need not require to replace casing and impeller. Similarly, here the sleeve material should be harder, not softer, should be harder than the shaft, and it can withstand, but it come in contact with the fluid, so it can withstand the corrosiveness of the fluid, as well as erosion is also stopped. So normally the sleeve material hardness, shaft material, if shaft material is carbon and alloy steel, its hardness should be 25 to 35 Rockwell hardness number, and base material of sheep should be 35 to 50, so 50 to 55 higher than the shaft. So in summary also, the shaft for shaft sleeve, it is telling the same thing, to protect the shaft from wear, corrosion and erosion, and some slightly inferior material can also be used. It can now the purpose of the shaft is to transmit the torque, so its strength should be just sufficient to transmit the torque, so it should not be SS or higher harder material, because it is not come in contact with the fluid. Then easy maintenance, there is no need of taking out the shaft from the bearing. Economical replaced, because expensive shaft material is very need not replaced. Stainless steel, bronze, and hardened steel or coated alloy is its material, and its hardness of the sleeve should be more than hardness of the shaft by 15 to 5 to 15 Rockwell hardness. Now, another two important parts, items we are going to discuss here, that is the throat bushing and throttle bushing. Throat bushing we are using in the discharge side of the pump impeller and it is mounted on the stuffing box. So that from the discharge, very less quantity of fluid, maybe the corrosive fluid, maybe the abrasive fluid, will go inside the stuffing box where mechanical seal and mechanical seal or where mechanical seal or gland packing are being used. And it pressure also to be maintained less. That's why the throat bushing are used. Throttle bushing are used from discharge side. That is, it is used for in the stuffing box to atmospheric. So the flushing water which we are using for the cooling of mechanical seal or gland packing, that should not go out from the stuffing box, as well as it maintain the throttle, it maintain the pressure of the stuffing box. So throat bushing between impeller and stuffing box, and throttle bushing we are using between stuffing box to outside. So it control the stuffing box pressure as well as minimize the expensive apart fluid to outside. Or throat bushing we are using to control the pressure and minimize and restrict the corrosive fluid or abrasive fluid to come in contact with the mechanical seal. Impeller backplate. Why you are using impeller backplate? Because the casing, impeller casing, is normally casted, and we know very well the casting material. There is very difficult to maintain the uniformity. So the axial clearance between impeller and the casing is difficult if we use simple casting. So instead of casting, we are using casting. We are using a back plate which is fitted on the pump body, so that you will get a uniform clearances and you can maintain a close clearances, so that this from the discharge side, impeller outlet side, flow will go through the inward and through throttling action, and this water, this fluid will go to the stuffing box, and that pressure will reduce, and sometimes it can go to impeller through this hole, that also reduced if you are maintaining a close clearances. And second important function is it prevent the replacement of expensive casing material. You just simply replace the impeller backplate, then your casing, expensive casing can be saved. Backplate, relatively inexpensive replacement of backplate when worn out, rather than the most costly replacement of entire pump casing, and it minimize the axial gap. So axial thrust is always, as the discharge pressure is less, will be less throughout the pump backside of the pump impeller. So axial thrust also you can balance. And as the leakage through the back plate and backside of the impeller is minimum, so your recirculation will also be less, and your stuffing box pressure will also be less, recirculation will also be less. So your it will save your gland packing as well as mechanical seal, as well as it will improve the efficiency. Then what is the purpose of the back vane? The back, if you see sometime, if you see the impeller backside, there is some radial chips, rifts are there. This is also an impeller blade. Example, also an impeller blade. These blades, the purpose of this blade is when the pump is running, from the discharge side, outlet side of the impeller, from discharge pressure will fluid pressure will high, and it will try to come inward. But due to this vein, it will not allow the discharge fluid to come inward, and because we are maintaining a very close clearance with the back plate, and with this hole, some suction fluid also can come to discharge side, and through this impeller through this is also you can say play like an impeller. So fluid will go outside, so it will not allow the discharge pressure to come inside. So what will happen? This pressure will be less. So axial balancing plus close clearances, recirculation will also be less, But in the particular case, what will happen, as this is working as an impeller, so some power increase may take place, and it will not allow, if the fluid is corrosive or foreign, and not allow and slurry material, then it will not allow the slurry material to come inward and come in contact with the shaft and slip. Next is the nozzle positions. You can see the left hand side drawing. The nozzle position, suction nozzle is in horizontal, discharge nozzle is vertical. If you see the second picture, here both suction and discharge nozzles are vertical. What are the advantage of horizontal suction and discharge vertical? Now your footprint, both the suction and discharge are vertical. Then what will happen? Your footprint requirement will be less space will be required, because suction line is not horizontal from the vertical. So less footprint will be there. It can withstand higher pressure, so your suction tank can be mounted on the top, so suction pressure will also increase. Adjust NPSH. NPSH, when we are going to discuss, NPSH is a very important function parameters of centrifugal pumps. So it can evaporate if temperature is high and pressure is less. So due to this vertical position, your pressure will be high, so NPSH can be improved. And no priming is required, as the suction and discharge pipe are from the top. There is no question of any trap air inside the impeller. So it will help. No priming is required, but only disadvantage is that you have to it require more headroom, so civil work will increase. Difficult to maintenance, but if you do the maintenance of the pump, you have to take out the suction and discharge pipelines. So for this some crane arrangement or overhead crane arrangement should be there. That's why maintenance is very difficult, and it's difficult. For horizontal suction and vertical discharge, it is advantage is the easy maintenance, and handle easy maintenance. Less headroom is required, so civil of the room size head, as there is no head is required, very less head is required. So this is the cost will be very less. But disadvantage is that the it requires more floor space, less efficient, because low pressure, you are not getting suction pressure high, suction pressure from the bottom, from the horizontal, so suction pressure will be less. So that's why you are less efficient as due to low suction pressure, and require priming, because as there can chances of air trapping. So this is the disadvantage of your using horizontal suction. Now I think I have clear all the spare. I have clearly told you the parts of all parts of the centrifugal pumps, its function, function, etc. I think if you go through these slides again, your all concept will clear. Clear. If you have any doubt, you can call me. My phone number already mentioned in these slides, and you can mail me also. I will get time, I will certainly reply you. But when normally when we are going to recruit some GET or any engineer in our industry, we used to use palm mechanical discipline. Normally palm is going to is a very important equipment. For that we normally used to ask the above questions, the following questions: main difference between positive displacement pump and dynamic pumps. That reason I have already told you. There is major component of centrifugal pumps, that is the rotating and rotating and fixed component. And then the purpose of wiring ring, that also I have told you. The purpose of a shaft slip, that also I have told you. And purpose of using back plate and back vane, that also I have told you. So I feel this will help you to appear in the interview board. And if you go through these slides, your all concept about the pump and its classification and its pairs will certainly be clear. Still, if you have any question, you can ask me in this mobile number or mail ID. Thank you very much.